Today I'm going to be talking about one of my favorite topics that we're going to cover in 6th grade, partly because it's used in day-to-day life and partly because it's one of the biggest things that we're going to talk about this year, and it is ratios. For now, all I need you to do is follow along, and later I'll ask that you get out your math workbook and open it to follow along with some workbook pages with me. But for now, I just want to talk about what a ratio is. A ratio is a comparison of two values, and we use this all the time. In our classroom, we have a ratio of boys to girls. We have a ratio of students to teachers. And we probably have a whole bunch of other ratios as well, such as students to tables. I could assign a value for all of these. For example, maybe boys to girls could be 12 to 12. We could have an equal number of boys to girls. Students to tables, we could have 6 students to 1 table. Whoops, I did students to teachers. I wrote it in the wrong spot. 6 students to 1 table. Or for students to teachers, we could have, say, 23 students to 1 teacher. So we represent our ratios with numbers. Now we're going to talk about what that might look like in your math workbook. I want you to go ahead and get your math workbook out. If you need to pause, you can. I already have my math workbook open to the page we need. Once you get your math workbook open, you're going to open to page 269. That's 269, and you'll see some test tubes here at the top. Now, while I write in my workbook, you are going to be copying the same information into yours. I'm going to read through each page and fill it in as we go. Feel free to pause the video as you need to fill your information in as well. I'm going to start with number 1 that says, you can use multiplication as a way to compare two quantities. In Nahele's lab group, there are 4 times as many test tubes as students. Complete the model to show this comparison. A circle represents a student and a rectangle represents a test tube. When we draw ratios, we typically are going to represent things using shapes because it's a lot easier than drawing the actual object. So in this case, we have test tubes represented by a rectangle, students as a circle. And if I go back and look at this, this says that there are 4 times as many test tubes as students. So I see that drawn right here, 1, 2, 3, 4 test tubes for every 1 student. And they want me to complete the model, so I'm going to keep drawing that in. Over here I see my 1 student, and I need to draw 2 more test tubes. Here's 2 test tubes to 1 student, so I need to draw 2 more. Now I have 4 test tubes for each 1 student. Part B says 1 more student is added to Nahele's group. How many more test tubes do you need to include in the model? So if I imagine going back up here, and I'm going to draw an arrow to show where I'm going to show my work. If I have to add 1 more student, I know that I need to add on 4 more test tubes. And I'm going to write 4 more right there. Part 2 says, you can use a ratio to compare 2 quantities. One way to describe a ratio relationship is to use the language for every or for each. And I'm going to underline for every or for each because that's going to be really important later. In Eldora's lab group, there are 3 test tubes for every 1 student. Complete the model to show this ratio relationship. So here I see, once again, they're using rectangles and circles. Rectangles are test tubes, circles are students. And I know that I have 3 test tubes for every 1 student. So I need to draw in 1, 2, 3 test tubes for 1 student. 1, 2, 3 test tubes for 1 student. And 1, 2, 3 test tubes for 1 student. Part B says, use your model to complete these sentences that use ratio language. For every 1 student, there are 3 test tubes. There are blank test tubes for each blank. I'm going to look up here and see there are 3 test tubes for each student. And right here says there is blank student for every blank test tubes. There is 1 student for every 3 test tubes. I'm going to turn the page. So now I'm on page 270. Sorry, my marker bled through just a little bit. And now I'm going to continue to draw some models to represent my ratios. The Spanish Club is having a party. They plan to serve 6 tacos for every 3 guests. Complete the model to show this ratio relationship. So if this is 1 taco, this is 1 guest, I know that I need 6 tacos for every 3 guests. So I'm going to have 1, 2, 3, 4, 5, 6 tacos and 3 guests. So 6 squares and 3 circles. Part B says, use ratio language to write 2 different sentences that compare the number of tacos and guests. I could write that as, there are 6 tacos for every 3 guests. I could also write it as, there are 3 guests for every 6 tacos. But I'm not going to take the time to jot it in here because I'm trying to shorten this recording a little bit. Part C says, Julong says that there are 2 tacos for every 1 guest. Use your model to help explain why Julong is correct. So if I think of this as 2 tacos for every 1 guest, I can come back up here and I can kind of see some groupings. If I know there's 6 tacos and 3 people eating them, every person's going to get 2 tacos. And I might be able to redraw that down here. I'm going to put T for tacos, G for guests. With 2 tacos for 1 guest, and I could circle that to show that that grouping works just like suggested. 2 tacos, 1 guest. 2 tacos, 1 guest. I still have 1, 2, 3, 4, 5, 6 tacos, and here I still have 3 guests. Number 4 says, explain how the ratios 5 tacos for every 2 guests and 2 tacos for every 5 guests are different. Include a model in your explanation. So I'm going to draw a quick model to show 5 tacos for every 2 guests. So I'm going to do T for tacos, G for guests, and the first one I'm going to show is 5 and 2. So 1, 2, 3, 4, 5 tacos for 2 guests. And then my second one is still comparing tacos and guests, but my second one says 2 tacos for every 5 guests. So now I have 1, 2 tacos, and I have 1,